So anyways, first thing I want to do, though, is I got to figure out what these values are. Now, I do have a scalar outside of my vector, correct? So therefore, I am going to need to distribute that. Then I'm going to use my handy-dandy calculadora. And I'll do 7 times cosine of 135. I'll round to the 100th. So therefore, I get negative 4.95 I plus 4.95 j. Now, again, I don't really like linear combinations, so I'm going to write this as component form. OK, so I'm not going to really involve myself with the unit vectors I and j. I'm just going to write in component form. Does everybody see what I did? Yeah, I mean, it's the same thing. It doesn't really matter. So again, the question is asking, find the magnitude and the direction of the angle. OK, so let's call this vector v. Well, usually we want to do u, v, or w. Those are kind of our standard ones. So let's call it v. So therefore, can we figure out the magnitude of v? Do I need to show the definition again, or could I calculate the answers so you guys can check your answers? OK, so I'm going to do negative 4.95 squared, which is really 4.95 squared, plus 4.95 squared, and then take the square root of that answer. And I get 7.000. Since I rounded those, I'm going to leave the magnitude as 7, because I had to round negative 4.95. I rounded those. So since I get 7.00, I'm going to leave the magnitude at 7. To find the angle, I have tangent of theta is equal to 4.95 divided by negative 4.95. So therefore, theta equals tangent inverse of negative 1. Well, fortunately, I know tangent inverse of negative 1. That's going to be a negative 45 degrees, right? Because we just did that problem. I remember the word problem, didn't we? Negative 45 degrees, or I showed it right there. And there you go. Done.